Hello everyone. This is session 1, Linear Inequalities. In this chapter, you will learn what are inequalities, algebraic solutions of linear inequalities in one variable and their graphical representation, graphical solution of linear inequalities in two variables, and the solution of system of linear inequalities in two variables. Let us know what is this inequalities. Inequalities tells us about the relative size of two values. It tells about the relative size of two values. Mathematics is not always about equals. Sometimes we only know that something is greater or less than. For example, if I take Suma and Tina have a race and Suma wins, right? If Suma and Tina have a race and Suma wins, what do we know from this? We don't know how fast they ran, but we know that Suma was faster than Tina. If Suma and Tina have a race and Suma wins, we don't know how fast they ran, but we know that Suma was faster than Tina. And we can write in the form of Suma is greater than Tina, right? Or S is greater than T. We are representing it in the mathematical form, the statement in the mathematical form. It is always translate a statement problem in the form of equation. Statement problem in the form of equation, that is inequalities. How we will write means using equation we have the signs, that is less than, greater than, less than or equals, greater than or equal to, and not equal to. These are the inequalities sign. Inequalities are similar to equation in that they are mathematical sentence. They are mathematical sentence. If as 5x plus y is greater than 6, this is a mathematical sentence. They are greater in that they are not equal all the time. They are different in that they are not equal all the time. And inequalities as finite, infinite solution instead of only having one solution like a linear equation. Inequality as infinite solution instead of only having one solution like a linear solution. These are the symbol of inequalities, that is less than, greater than, less than or equals, greater than or equals, and not equal to. And here it is shown here the boundary line that we will go for the variable of two variables. We'll go for, this is used for the two variables, the graphical representation of two variables. The inequalities are, the four inequalities here is greater than, less than, greater than or equals, less than or equals, or we can say not equal to. Let us see the types of inequalities. There are numerical inequalities, literal inequalities, double inequalities, strict inequalities, slack, quadratic inequality, and we'll come to what is linear inequalities. The main topic of this lesson is a linear inequalities. Before moving to that, we'll see what is in different types of inequalities. Numerical inequalities. If only number are involved in the expression, then it is a numerical inequalities. If only numbers are involved in the expression, that is a numerical inequalities. The example is shown here. 10 is greater than 8 and 5 is less than 7. This is what is shown as, this is inequalities. Inequalities, it is less than, it is inequalities symbol, right? Numerical inequalities means if only numbers are involved in the expression, that is 10, 8. These are the numbers are involved in the expression. This is what is the expression is. First expression and second expression. This is in the form of the mathematical equation, right? Mathematical. The statement is converted into mathematical equation. Numerical inequalities are involved in the numbers are involved in the expression, then it is numerical inequalities. Next, the literal inequalities. These are the examples of the literal inequalities. By seeing this, you can observe here one variable and a number involved in the expression, then we call it as literal inequalities. That is, x is less than 2, y is greater than 2, x is less than 10. These are the example for the literal inequalities, whereas the numerical inequalities in the numbers are only numbers are involved. Here one variable, that is one letter, and one number is involved in the literal inequalities. Literal inequalities. Then we'll see the double inequalities. I will read this. 5 is less than 7, less than 9. Read as 7 less than 9 and greater than 5. We can read. This is an example of double inequalities. So there is a double digit, so we call it as double inequalities. 5 is less than 7 is less than 9. We can say it is a double, right? So it is a double inequalities. Next, it's strict inequality. If the mathematical expression involve only less than or greater are called strict inequalities. There is no equal sign here, right? Mathematical expression involve only less than or greater are called linear inequalities. The before example that is shown is also, we can say it is a strict inequalities, right? The any expression if it is involved, but if it is less than or greater than, that is, we call it as strict inequalities. Mathematical expression involve only less than or greater are called strict inequalities. Slack inequalities. If the mathematical expression involve less than or equals or greater than equals, it is shown clearly here, less than or equals or greater than or equals, right? Less than or equals or greater than equals. This is the symbol that is for inequalities, right? Inequalities means it is not equal, that is less than, greater than, not equal to, less than or equal, greater than equal. These are the inequalities symbols. Slack inequalities is a mathematical expression involve only less than or greater than are called slack inequalities. Slack inequalities. Quadratic inequalities. By seeing this example, we can note here, right, it is not an example of linear inequality. The main topic here is linear inequalities, means it is one variable because the exponent of x is 2 in the first term. We can see here the main thing of this chapter is the linear inequality, right? Linear means it contains one variable, where here it contains the two variable. The first term, the exponent of x is 2 here, right? Exponent is 2. So we will say it is an quadratic inequalities. We'll say it is an quadratic inequalities. What is linear inequalities? You know that linear inequality is an inequality which involves a linear function. It contains one of the symbol of inequalities, means it is less than, or it may be greater than, or maybe it is equal to, right? It is a mathematical statement that relates a linear expression as either less than or greater than other, right? It is a mathematical statement that relates a linear expression as either less than or greater than another. If it is contains one variable, it can be written as ax plus b is greater than 0 in standard form, with a is not equal to 0 here, because it should contain one variable, that is x here. It is shown here, that is x. It is x, right? So it includes what? Greater than, less than, or greater than equal, less than equal. The standard form is ax plus b. The first variable, the exponent of the first variable is, we will say it as the linear inequalities. The one variable we call it as linear inequalities. If it is many more than one variable, we will say it is a quadratic inequalities. How to solve the linear inequalities? Solving a single linear inequalities is pretty much same process of linear equations we used to solve in the earlier classes, right? We will simplify both sides, get all the terms with one variable on one side and the number on the other side. Used to solve in the previous classes, that is used to solve in this the previous classes, like by taking simplifying the both the side, get all the term with the variable on one side and the number on the other side, and then multiply or divide both side by the coefficient of the variable to get the solution, right? The earlier classes used to do this. Same thing, the solving by two-step inequalities. Our aim is to have x here, or whatever the variable is, on its own on the left of the inequalities sign. We'll take the left side any variable like x, y, that is shown here, right? X, y. Our aim is to have x or whatever the variable on its own on the left of the inequalities, on the left of the inequalities sign. This is add or subtract, right? Add or subtract to isolate the variable term. Next we can multiply or divide. Multiply or divide. When adding linear inequality, when solving the linear inequalities, we use a lot of the same concept that we use when solving the linear equation, right? Basically, when we still want to get the variable on one side and everything else on the other side, that is one number one side and variable one side, by using it. Basically, when we still want to get the variable on one side and everything else on the other side, by using the inverse operation, right? The difference is when a variable is set equal to one number and the number is the only solution. But when a variable is less than or greater than a number, there are infinite number of values that would be a part of your answer. Here you can add or subtract to solve the variable term, multiply or divide to solve the way for the variable. If multiply or divide by a negative number, then reverse the inequality sign. We'll learn this by using taking an example. Many simple inequalities can be solved by adding, subtracting, multiplying or dividing both sides until you are left with the variable on its own, right? But these things will change direction of the inequalities. When means multiplying or dividing both sides by a negative number, or we can swapping left and right sides. By swapping the left and right side, don't multiply or divide by a variable unless you know it is always positive or always negative. It is always positive or always negative. If I take this example, so here x plus 2 is less than 12. Our aim is to have the x at the left side, right? So you can see the number 1 here, right? Left side means if I take the inequality signs here, this is considered as left side and it is a right side, right? Left side and right side. If I take this x plus 2, inequality sign, you can see here, this is the left side and right side. So we can observe here one number from the variable x along with the variable x. You have to subtract that number for the both the side, that number. So what you will get, x plus 2 minus 2 is less than 12 minus 2, because we want only the x term there. Simplify, we will get what is plus 2 minus 2, it is 0, is less than 12 minus 2, 10. You got the exact x value. Your aim is to solve x, so it is solved, right? And if I take this example, see what you will do means 3x plus 7 less than 16. After solving this, we will use it in the graphical form. The graph of a linear inequality in one variable is a number line, right? The graph of a linear inequality in one variable is a number line, whereas two variable, we can see the boundaries there for quadrants there. We'll study in the next session. Here, let us solve this problem. See, you want only the x term here, right? So first remove this. So by subtracting with the minus 7, what you will get, 3x plus 3x plus 7 minus 7 less than 16 minus 7, you will get 3x less than 9, right? 3x is less than 9 you will get. After that, you don't want this, you want only both the exterm. So we will divide it. You can't multiply it by 3, right? If it is a multiplication, you have to divide. If it is addition, you have to subtract it. So if it is a multiplication, 3 into x, right? Divide it by 3, will get 3 get cancels, and so 3 3s are 9, you will get x is less than 3. X is less than 3. So your graph of a linear inequalities. We'll study this. Graph of a linear inequality in one variable is a number line. Use an open circle for less than or equals. It is open circle for less than or equals, and closed circle for less than or equal to, greater than or equal to. You can observe here clearly, less than or greater than, it is an open circle. It is shown here, right? This is an open circle. And closed circle, that is an shaded portion. If it is less than or equals or greater than equals, it is shown here, right? If it is only simple less than or greater than, we will use a open circle, right? Open circle. If it is less than or greater, we will use an closed circle, shaded, right? Inequalities have the same solutions, are called inequalities, right? Equivalent. So we can see the example over here, and the same after solving this, so we have to represent in the graphical form. So x is less than 3 means what? In the number line, to form the number, right? Number line, it is 0, here it is a positive, here it is a negative. What we got is the positive 1. From 0 we will go from here, so I have not taken the negative here. This should be written because it goes to infinities. So why we marked the see, this is what is the open circle. Open circle is for less than or it is greater than. If it is less than or equals, we will use the shader there. So it goes to 0 to, sorry, not 0, it is from infinity to, goes to 3, right? 3 to infinity, or it goes the exact 3 you got, 3 to infinity you got, right? We'll see here, and we are using the bracket here, right? When we will use for the this kind of bracket means, see, when you have the open circle, we have this. When you have the closed circle, we have the big bracket. When you have the close open circle, we have the small bracket. When we have the shaded portion, we have the big bracket over here, right? We'll see through the problems in the next coming session. So see here, just look at the number line. For example, it is shown here 3 2 is an increasing, but minus 3 to minus 7 is an decreasing. So how the inequality sign reverses here, we can see from this. In the next session, we will study what the graphical representation by using of the linear inequalities of two variables. Here we learned for the one variable. Thank you.